So today we'll be doing MCQs of alkyl halide part 5. Okay, we are continuing our videos. Okay, so the question is CS3 BrKO plus KOH, which gives CS3OH plus KBr is an example of option number A is nucleophilic substitution reaction, option number B electrophilic substitution reaction, option number C both nucleophilic and electrophilic, both NSR and ESR. Yes, R, and D is your none. Okay, so let us understand this. Look, this is your primary alkyl halide. This will exclusively undergo SN2 mechanism, right? SN2 mechanism. What is SN2 mechanism? Suppose this is your CS3Br, and we react this with KOS. This will give OH minus, right? This nucleophile will attack this from backside, and now this will be CS3, and here it is OH, and this one is BR, right? This is your delta positive, this is your delta negative, this is your delta negative. Now this will form CS3OH plus Br minus, and this will be reacted with K plus, right? This will be reacted with K plus to form CS3OH plus KBr. So look here, this is your nucleophile, right? This nucleophile attacks this CS3 from backside and this replaces Br, right? Substitute Br. So this is nucleophilic substitution reaction. Okay, so the next question that will be dealing, so which of the following does not form ethyl chloride from ethyl alcohol? Okay, which of the following will not form ethyl chloride from ethyl alcohol? Okay, first is Cl2, second is Cl2 plus P, third is conc HCl, fourth is PCl3. So we have seen that this either from PCl5. So all of this actually, these three reacts with ROH to form RCl, right? But direct chlorination will not form ethyl chloride from the ethyl alcohol. Okay, next question that we're going to discuss over here is, okay, when chloroform reacts with HNO3, when chloroform reacts with HNO3, so what will be formed? Okay, what will be formed? So first option is CHCl3 NO2. Option number B is CCl3 NO2. Option number C is CaCl3 HNO3. Option number D is CHCl2NO2. We know this reaction. When CHCl3 is reacted with HNO3, this was forming CCl3 dot NO2, which was, this is called as uh, chloropicrin, right? Chloropicrin. And okay, chloropicrin, this is also called as your war gas, right? War gas. So next we'll be discussing now identify Z. Okay, it is said that identify Z in the reaction. Identify Z in the reaction, and the reaction is like this. This is your C2H5Cl when reacted with alcoholic KOH gives X. This is reacted with bromine. The reactant, this is reacted, okay, this forms Y, and this is reacted with KCN and forms Z. So we have done this type of questions. Okay, this is dehydrohalogenation reaction. This will produce CH2 double bond CH2 when reacted with bromine. This will form CH2Br. This is also CH2Br. And when this is Cn, then with KCN, then Cn minus will be produced, and replacing this Br, then this will be forming this one. So we have dozens of questions. So next question. Okay, it is said that carbon halogen bond is strongest among the following. Okay, so the question is carbon halogen bond is strongest among of the following. Among which of the following carbon halogen bond is strongest? That is your CH3Cl. B is CH3Br. CS is CH3F is, and D is CH3I. We know electronegativity order, right? That is F, fluorine, chlorine, bromine, and iodine. This is the most electronegative, right? The bond will be much stronger in this case. So the next question is alkyl halide. Okay, alkyl halide are heated with Ag2O. Okay, the compound formed would be so option number A is ester, option number B is ether, option number C is ketone, option number D is AgCl plus hydrocarbon. So let us see the reaction. So this is your, suppose Ag2O when reacted with Rx, right? So look at 2 Ag, so let's take 2 mole of Rx, so this will form 2 AgX plus, and this O will be here, so this will be ROR, right? ROR. So this is actually your ether. So the next question that we are going to deal over here is cyanoform is dash acid than chloroform. Cyanoform is dash acid than chloroform. Okay, option is stronger, B is weaker, C is neutral, and D is both acidic and basic. So both acidic and basic. So while understanding this, suppose this is your CN, and this is your H, and there is chloroform. Suppose this is Cl, and this is H. So this will be withdrawn electron toward itself, right? So you must remember one thing: Cn minus is more electronegative, okay, than the chlorine. So this will uh, attract electron toward itself, so that hydrogen can be liberated easily, right? Hydrogen can be liberated easily from here than here, right? So hydrogen ion giving tendency, right? Giving tendency in case of cyanoform is more than chloroform, right? Chloroform. Hence, cyanoform is stronger acid than chloroform. That is what we are trying to find out. Okay. Next question that we are going to discuss over here is, let's say, okay, chloroform with nitric acid. We have already seen chloroform with nitric acid gives what? Chloropicrin, right? Next question, iodoform when reacted with KOH. Iodoform when reacted with KOH, it gives what? A number as COOK, B number CS3 COOK, number that is your HCHO, or D number CS3 CHO. You must remember, when we react this with KOH, this gives HCOOK, okay, potassium format. Next question, that is your, okay, when chlorine is passed through propene at 400 degrees Celsius, which of the following is found? Okay, when chlorine is passed through propene at 400 degrees Celsius, which of the following is formed? Which of the following is formed? Option number A, that is your allyl chloride, allyl chloride. Option number B, that is a PBC. Option number C, vinyl chloride. Option number D, that is your 1,2-dichloroethane, 1,2-dichloroethane. Okay, let us see. So this is CS3, CS double bond CS2. When we react this with chlorine ideally, so this should give addition reaction, right? Because this is unsaturated hydrocarbon, so addition reaction should be given to produce this. Okay, but here is a condition, that is your we heat this at how many degrees Celsius? 400 degree Celsius, and then we are reacting this with chlorine. So at higher temperature, you should remember, at higher temperature substitution reaction takes place. Substitution reaction takes place over addition reaction. Okay, addition reaction. So this will give actually CH2Cl, CH double bond CH2. So this is allyl chloride, right? This is allyl chloride, right? This is your allyl chloride, right? This is an allylic carbon. Chlorine is added on the allylic carbon. Okay, so option number A is the correct answer. So now we'll be looking at the next question, that is your, which of the following alkyl halide is used as methylating agent? Which of the following alkyl halide is used as alkylating agent, right? And given here is C6H5Cl, B number is C2H5Cl, C number is CS3I, and D number is your C2H5Br. So this one we have already discussed this question many times. Okay, so next question, among MEX, RCH2X, R2CHX, R3CX, which is most reactive? Which is most reactive toward what? SN2 mechanism. Okay, so option is R3CX, B is RCH2X, C is MEX, or D is your R2CHX. So we know that for SN2 mechanism, remember once what was SN2 mechanism. Suppose this is CS3X, then there was nucleophile which was attacking it from backside to form an intermediate, that is your nucleophile, right? CS3X complex, and then this was giving CS3NU plus X minus, right? This was the process. So if there is more steric hindrance, right? SN2 reaction is actually, if there is more steric hindrance, it will not take place. It will not take place by SN2 mechanism. So SN2 mechanism will happen if there is less what, steric hindrance, right? If there is less steric hindrance, so this will be the order. Right, in this order they will be reacting. So look over here, this is CS3X, so this will be giving SN2 reaction rapidly, right, than any of this. So next question, let us move to the next question, and the next question is okay, SN1 reaction of alkyl halide leads to SN1 reaction of alkyl halide leads to, first of all, you must understand, it leads to retention of configuration, and secondly, you must remember, it leads to racemization. Okay, SN2, this leads to inversion. This leads to inversion of configuration, right? Inversion of configuration. This leads to inversion of configuration. Okay, next question. Arrange the following halides in decreasing order of SN1 reactivity. Arrange the following halide in the order of decreasing SN1, in the order of decreasing SN1 reactivity, and given to us is one is your CS3 CS3 CH2 CH2 Cl. Second is CH2 double bond CH Cl CS3, and third is your CS3 CH2 CS3 CH2, okay, CH Cl CH3, okay, this one. So you have to arrange this one, okay. So option A is your increasing order, decreasing order, okay, that is 1 is greater than 2 is greater than 3. Option number B is 2 is greater than 3 is greater than 1. Option number C is, that is your 2 is greater than 1 is greater than 3. Option number D is 3 is greater than 2 is greater than 1. So let us see here actually what is SN1 reaction. SN1 reaction, intermediate is what? Intermediate formed in SN1 reaction is actually carbocation, right? Carbocation, right? So stability of carbocation, if we have to talk, then first of all you need to understand this fact that benzylic carbocation, benzylic carbocation is more stable than allylic carbocation is more stable than third degree carbocation, then second degree, then first degree, then CH3. Okay, so let us see over here. This is benzylic. I'm sorry, this is your allylic. Look over here. Here is the positive charge, and this positive charge will actually delocalize from here, right? So this is your allylic carbocation, right? This is your, this one, look over here. This one, look over here. This is your secondary carbon. So this is your secondary halide, right? So this will form secondary carbocation. This will form primary carbocation. Okay, so let us arrange this one. So this will be more stable carbocation. So 2 will be the, this is second degree, so this is 3, and this one is the first degree, this one is the first degree carbocation, so this is your 1. So 2 is greater than 3 is greater than 1 will be the correct answer. So the next question that we are going to discuss over here is, what happens the reaction between alkyl halide and RCOOAg? The reaction between alkyl halide and RCOOAg produces, okay, A number is ester, B number is aldehyde, C number is your ether, D number is your ketone. So let us see. This is R, C double bond O, O, A, Z. When it reacts with this alkyl halide, then this will go out, and this will form R, C double bond O, O, R. This is what? This is your ester. So the next question that we are going to discuss over here is, okay, unpleasant smell of carbylamide. Unpleasant smell of carbylamine is obtained, okay, when chloroform, when CHCl3 and alcoholic KOH reacts with, A number is any amine, no, not with the secondary amine. B number, any aliphatic amine, no. C is any aromatic amine, no. And D number is any primary amine. This is right, whether it is aliphatic or aromatic. So any primary amine will actually give what? Carbon amine reaction. Okay. So now we will be doing other questions in the next part. If you are new at the channel, please do subscribe, because I will be solving all the questions of organic, okay, before CEE arrives.